direction must to keep that bar from falling. Well, if you wanted to keep something from falling, you have to push it up. Show me your hand for pushing. Okay, now put your thumb in the direction of the current in that bar. So I know I got to push up, right? But which way is the current moving in the bar? That way. So which way does the field have to point in order for this bar to stay there? Do you get it? This is not the field caused by the wire. This is an overarching field that must be there in order for the wire to stay up. Because they're saying you pump a current through this and it levitates. Why? You say, well, nothing levitates by itself. So something must be holding it up, and we're in the chapter on magnetism. So I think the magnetic force is going to hold it up. And then you say, what's going on in this? Well, this is a circuit. So there must be a current. Current is my thumb, fingers are my magnetic field, and my palm is pushing up. That's why that field goes that way. Because the field is already there. We are not identifying the field caused by the wire.
Because if it was the wire, then it'd be external.
Yes.
Oh, they're giving.
Yes. Because if there was just a wire and there was no external magnetic field, would this levitate? No, it would just fall down. Okay, does this make sense? Okay. So the answer for part A is into the page. Then for part B, if the magnetic field is properly directed, what must its magnitude be to keep the crossbar stationary? So, for part B, in order for this thing to stay levitating, we know what must be true about the forces. Thank you. Some of the forces in the Y must be equal to 0. Does that make sense? So, what are the two forces? What is one of the forces? Come on. Okay, obviously, we're in the chapter on magnetism, so one of them must be that. And come on, what's the other one? Gravity, right? So we know that it's Fg, and what did I do, minus? Yeah, they're opposite directions, yeah? Fg points down, always. So then I get Fb equals Fg, so I get BIL equals mg. What are we looking for? B, right? So B is equal to mg over IL. I'm just going to use 10 for G. So it's going to be 0.3 on top. And then I is EMF over R. So that's going to be 5 amps. So it's going to be 0.3 divided by 1. Cool. So the answer is 0.3 Tesla.